That sounds good. That looks good. Can you do it in presentation mode?
Yeah, let me get that. Oh, okay. Now I'm not sharing the right, I might not be sharing the right entire screen. Here we go. All right, there we go.
Excellent. That's great. Hey, it is great that you were able to be with us. As everyone knows, harmful algal blooms, pose a serious threat to our water resources because, they're not only harming ecosystems and fisheries, but they prevent recreation and impacting local communities. Amelia Jones is a senior engineer and project manager at TRC with 7 years of experience in managing harmful algal blooms and implementing sustainable water treatment solutions. Today, she's going to tell us about intervention strategies, including algicides, peroxide treatments, oxygenation, and reservoir operations, managing nutrient sources, especially through sediment inactivation like alum treatment, which I think is an interesting approach. Amelia's background includes a master's in civil and environmental engineering from UC Davis, where she developed automated models to analyze ecosystem metabolism in Lake Tahoe. With that, Amelia, it is great to have you with us. Take it away.
Thank you. Yeah, and I actually, this is a great timing for this presentation. I just got back from Lake Tahoe. The North American Lake Management Symposium was held there this year. And I did present, I did a presentation on drones, which I haven't really incorporated into this one, but if anyone has questions about using drones for monitoring, specifically my presentation was a cost benefit analysis for lake managers, because I'm very interested in using them, but I keep hearing how cost effective they are. And I kind of wanted to like really evaluate exactly how cost effective they are when compared to some of the more traditional or conventional water quality monitoring techniques that we tend to use. I didn't really get a chance to incorporate that into this presentation, and plus it's already a little long, so I'm kind of going to zoom through the introduction parts. Most of the intro stuff to HABs I'm going to kind of cover very quickly, but if you do have other questions about HABs or harmful algal blooms or anything, I'm happy to answer those after, but I definitely want to focus on in-lake management strategies, because especially at this conference, every year it's becoming clearer to lake managers that in-lake management is becoming unavoidable. And we can do all we can to manage these nutrient inputs into our lake. But with the, non-point nature of some of the stormwater inputs and the impacts of climate change, it's just becoming almost impossible to prevent that eutrophication of water bodies, and we're starting to need to just get right into the lake and manage them directly. So I'll start off with a quick introduction. Harmful algal blooms. Hopefully most of the folks here on the call are relatively familiar. So I just want to point out that algae are good. So there are good algae, and algal blooms aren't necessarily harmful by nature. So, there are good algal blooms. They provide, an important food source for many aquatic animals, but sometimes large blooms can be a problem when the growth is excessive and uncontrolled. And, sometimes we see them produce cyanotoxins, which are caused by cyanobacteria. And that is harm to our ecosystems, our drinking water reservoirs, our recreational reservoirs, because they produce toxins that are irritants to humans. There's been dog deaths, pet deaths associated with them. Also wildlife deaths, fish kills. I know on the coast of California, we've had, sea lion deaths, dolphin deaths. Somebody recently told me that, apparently on the Northern California coast. They've just recently they've stopped the crabbing because there's a marine algal bloom that's producing toxins, and so they've issued like a no crabbing order, and so no people cannot fish for crabs. I don't know if it's called fishing for crabs, but whatever. You cannot get crabs. I am going to focus on freshwater algal blooms, FYI, for this presentation, but marine algal blooms are also a risk. I know in Minnesota, you guys probably don't deal with those so much, but they're a risk here in California and other coastline states. Why are HABs a problem? I've kind of already touched on a lot of these things, but they cause toxins and irritants that cause serious health effects in people. They impact our drinking water treatment if you are eating contaminated fish or shellfish, or you accidentally swallow water during swimming. And you can even breathe in aerosolized cyanotoxins in water spray or mist. Other exposure routes, fruits and vegetables that may be irrigated with cyanotoxin contaminated irrigation water. It's definitely a problem on agricultural lands. And then also there has been dietary supplements that have been found to contain cyanobacteria. And it can affect your skin, eyes, nose, mouth, throat, lungs. The most common kind of health effect is like a acute respiratory illness, and liver impacts and nervous system impacts. Short-term health effects are pretty well understood, but there's emerging research that suggests there might be long-term health effects as well for people who live next to water bodies. For example, Lake Erie is up here. I think, those of us who are familiar with harmful algal blooms know Lake Erie experiences them pretty much annually, and they can get pretty bad there. We also have a lake here in California called Clear Lake, another lake that experiences pretty routine and severe algal blooms. And so the folks that live on the boundary of those lakes, there's emerging research that suggests they may be exposed to long-term health effects from living next to those recurring algal blooms year after year. In the environment, they affect wildlife, mammals, fish, and birds. There really isn't any wildlife that's not impacted by a harmful algal bloom if one occurs on the water body that they use. And wildlife really are the animal, when you compare, humans and wildlife, that are the most affected. In 2021, there were almost 3,000 animals that got sick from harmful algal blooms, and about 92% of those animals died from their exposure. And in contrast, in 2021, there were about 120 human illnesses and no human deaths. So it's pretty rare for a human to experience such severe impacts that they would die, but certainly our wildlife, our pets and livestock, they're really susceptible. So that's definitely a major issue for wildlife, pets, and livestock. And then economic, higher drinking water treatment costs, loss of livestock and crops. Recreation is a big one, having to close beaches, losing tourism revenue, closure of fisheries. All of those have an impact on water bodies that rely heavily on those revenue sources in the community. Property value is also a major issue. If your property's on a lake that's experiencing regular harmful algal blooms, people are, not really inclined to live next to a really stinky, smelly, potentially toxin-riddled lake. So that's an issue as well. And then, some of the economic impacts just can't be quantified. Like I mentioned, the long-term health effects, that has an economic impact in terms of like receiving medical attention, getting treatment for some of these undiagnosed health effects that you might be attributed to exposure to HABs, but haven't really been fully diagnosed. And HABs are increasing in frequency and intensity. We're seeing lakes that have never experienced harmful algal blooms are suddenly experiencing them. There was a really interesting presentation at this NALMS conference, a lake in Maine that is, there is some agricultural development on surrounding lands, but, for the most part, this lake does not have a whole lot of human development around it. And the watershed agency that manages the watershed around the lake has done a really good job of kind of, preserving the land around the lake and buying up that land and keeping it kind of virgin land and keeping the native species there. And yet that lake still experienced harmful algal bloom recently, and the watershed agency was very confused by that because this is not a lake that experiences a lot of industrial or urban runoff, certainly some agricultural runoff, but not a whole lot, and it was pretty heavily controlled. So that led them to suspect that climate change was having an impact on that lake's eutrophication process. And so the presenter gave a really good presentation on kind of digging into that. And it's a little scary to think about a lake that is in a pretty rural and not undeveloped area that could still be pretty susceptible to harmful algal blooms just because climate change is speeding up that eutrophication process for those lakes, even if they're not receiving significant runoff. So that being said, nutrient pollution is a huge issue for most of our lakes. I like this figure here on the right from the EPA. The Mississippi River Basin, I think, is a really good example. Of course, the Gulf of Mexico is not a freshwater lake, but the drainage area into the Gulf of Mexico is huge. There's 31 states that ultimately drain runoff into the Gulf of Mexico, and those 31 states all contribute nutrient pollution into this water body, and that affects states like Florida, who don't even really contribute runoff to the Mississippi River Basin, but they would still experience the effects of a red tide in the Gulf of Mexico. So that kind of points to the need for national level coordination to manage the runoff from other states. There's a lot of lakes where the watershed spans multiple states. Lake Tahoe is one of them. It's on the border of California and Nevada. So California and Nevada have to work together to manage the watershed in Lake Tahoe. And so there's a lot of coordination that needs to happen on a state level and a national level, and then working with agricultural developers, industrial developers, urban municipalities that are all in that watershed to control the runoff that's going into those lakes. On a federal level, there are no enforceable federal regulations or standards to address cyanobacteria yet. It's on the EPA's contaminant candidate list, and it has been for quite a few years, but they still haven't come up with anything to they haven't issued any federal standards. There are some health advisories and recommended recreational water quality criteria and swimming advisories, but there's no federal standards yet that are enforceable. That being said, states have kind of taken the lead on this. I've got you guys, Minnesota Pollution Control Agency. You do have some cyanotoxin levels for swimming advisories, and they are based on the US EPA draft recommendation. There are a number of other states that have also come up with recreational water guidance and action levels. I believe I saw that the Minnesota Department of Health also has some microcystin, which is a cyanotoxin. You see it listed there as one of the cyanotoxins that's on the MPCA's cyanotoxin levels. I believe they have a microcystin level for drinking water. So states are really kind of leading the way on this in the absence of federal regulations. Ohio is the most proactive state, most notably because of Lake Erie. And Oregon is also a pretty active state. They've experienced a lot of algal blooms in a number of drinking water reservoirs. And I think these two states will be followed by many more. But I think these two states really got proactive about it because they had harmful algal blooms that actually affected a municipal drinking water supply. So in 2014, there was a major HAB on Lake Erie that prompted the city of Toledo to issue a do not drink order for tap water. And that affected almost 500,000 people for 3 days. 100 people got sick. And it was the US's first recorded drinking water associated public health outbreak caused by harmful algal blooms. So after that happened, Ohio got pretty serious about harmful algal blooms on Lake Erie, and Toledo and the other municipalities that border Lake Erie are very active in managing that lake and managing harmful algal blooms in drinking water. And similarly, Oregon had a toxic algal bloom on a lake called Detroit Lake, and that affected the drinking water supply in Salem, Oregon. And they also had to issue a do not drink order, and it was the water was potentially hazardous for people to drink. So that prompted Oregon to start getting serious about their regulations with regards to cyanotoxins in drinking water reservoirs as well. So now I'll shift into some of the monitoring for HABs. So typically monitoring for HABs kind of follows a, this three-piece kind of phased approach here. Most of the time, HABs and monitoring for HABs, there's some kind of trigger incident that indicates you need to start, monitoring for HABs. Either you see a harmful algal bloom on your lake, somebody gets sick, you have a recorded pet death, and so somebody will go out, screen for cyanobacteria, test for potentially toxin-producing cyanobacteria because not all cyanobacteria produces toxins, and then test for toxins to determine, what's going on in the lake. Then if you want to implement some sort of management strategy, it's really crucial to do an initial limnological assessment and water quality monitoring program. So these two pieces are composed of some, conventional water quality monitoring. So going out into the lake, taking readings of pH, temperature, turbidity, Secchi depth is another reading. So basically measuring the clarity of the water, testing for chlorophyll A, and then generally collecting water quality parameters or other, nutrient measurements that would help you determine how your water body is experiencing HABs. What's the HAB life cycle in your water body? Where are the nutrients coming from in your lake? And then also this water quality monitoring program serves as a long-term quantification of any kind of treatment effectiveness. So if you apply a peroxide or some kind of sediment nutrient inactivation treatment, you're going to want to be able to prove that actually worked. So those water quality monitoring parameters will help you measure the effectiveness of your treatment. And then if you perform that continued water quality monitoring, it can serve as an early warning system for future declines in water clarity or water quality. And you can kind of mitigate beforehand if you see the water quality is declining. You might be able to get out there a little earlier and prevent a severe HAB from happening on that lake. So monitoring approaches kind of just talked about this, so I'll go over it again really briefly. There is the evaluation of the presence of a HAB, which is, testing for the cyanobacteria and the taxonomic composition of the algae that you have in the lake, which is mostly just taking samples. There really aren't a ton of remote sensing or instrumentation methods beyond grab water samples that have emerged for this purpose. So grab water samples are really the gold standard for this type of analysis. You have to take a sample, send it to a lab, get it under microscopy, and figure out what kind of algae you're working with. And then there's the evaluation of the water quality to support your management decisions. So monitoring additional water quality parameters, maybe implementing a more long-term monitoring program, and that could include some high-frequency monitoring equipment, platform-based sensors like you see here in the photo. There's this monitoring buoy, which there's some data loggers attached to it, and it's consistently taking high-frequency data and transmitting that data to like a data dashboard that our engineers are monitoring on a regular basis just to track the almost daily water quality of the lake. So I'll go over this really quickly. It's kind of a busy slide, but this is just sort of the different methods for screening for cyanobacteria. When you've got a HAB in your lake, you're going to want to go out there and do a visual assessment, maybe a jar and stick test. That's sort of the initial kind of on boots on the ground, like, is this a HAB or is this just kind of a less maybe a harmless algal bloom, just a traditional one that won't produce toxins. So there's a couple different sort of qualitative tests you can do for that. Remote sensing is also becoming really popular, using drones to capture imagery and then relating that imagery to chlorophyll or other direct measurements that you're taking in the lake. And then you can kind of get a spatial representation of chlorophyll concentrations in the lake. And then when you have gotten your sample and you want to take it to the lab, microscopy is for determining the algal taxonomic, the presence of different types of algae that you have in the lake, counting the number of cells. Again, this is kind of the gold standard. I don't think this will ever go away because there really just isn't any kind of remote sensing or equipment that can do this type of work, although people are certainly trying to develop it. And then other genetic methods for identification. These are typically a bit more expensive if you want to really get into the target organisms and the DNA of the algae that's in your lake. Sometimes it's necessary, sometimes it's not, sort of depends on the needs. And again, testing for toxins, this is sort of goes hand in hand with the algae taxonomic identification. If you can identify the algae as a cyanobacteria producing algae, you might want to test whether or not it's producing toxins, because like I said, not all cyanobacteria produce toxins. So these tests will give you a quantitative estimate of how much toxins that algae is producing in your water body. You'd get like a volumetric concentration for your sample, and then you could apply that, to the volume of your lake and get an estimate of, how many toxins, what's the concentration of toxins in your lake, and is it a risk to the public? Do I need to close the beach? Do we need to notify the drinking water treatment plant? Do we need to do something to eliminate the toxins in the lake? So these are kind of a list of the currently available tests, and they're all really lab-based for determining toxins. So monitoring methods for water quality, like I said, these water quality monitoring goals are really to assess the water body as a whole, determine its overall conditions, identify stressors, um, identify seasonal changes, whether your water body stratifies, when it mixes, what are the sediments like, what are the inputs into the lake, and what's coming into the lake through those inputs, shallow groundwater quality along the shoreline, and then maybe you'd also want to assess some of the other biology in the water body. If you've got sensitive fish species or other sensitive ecosystem drivers that would impact any kind of management decision that you want to make. So there's a lot of parameters that you can measure. You don't have to really measure all of them, but certainly having all of these parameters and information on all of these parameters is really helpful in determining what is going to work as far as management in your reservoir, because not every management decision is appropriate for every reservoir. And if for folks who aren't familiar with the Secchi disc, this is the Secchi disc in the top right, that A and B. So A would be, a Secchi disc in a kind of more clear water lake, and then B is a Secchi disc in a lake that is experiencing likely a HAB. And then there's some other pictures of some other typically used monitoring sensors and buoys. So now I'll talk about nutrient management. So this is a really important part of that initial limnological assessment. You're going to want to figure out what your nutrient sources are from the watershed and develop a nutrient budget for your lake. So nutrient sources can be internal, external, natural, man-made, local, global, discrete, and diffuse. So they come from all over. So nitrogen and phosphorus are the main nutrients that we want to monitor for. Certainly in freshwater bodies, phosphorus is usually the problem causer, but it's important to also have a sense of nitrogen and the nitrogen budget in your lake as well. For marine HABs, nitrogen is usually the problem, so that's kind of the differentiator between freshwater and marine HABs. There is some federal funding currently for doing this kind of evaluation in your lake. So if you suspect that your lake has a nutrient problem, there's funding through the Clean Water Act to perform the nutrient assessment. And then there's also funding to implement some kind of management strategy. And then there's also, state funding for those kind of investigations as well, and then other funding sources through government and foundations that you can seek out to get this assessment started. Controlling watershed sources of nutrients. So this gets complicated, but generally for discrete stormwater sources, so like a point source, stormwater B&Ps and retrofits are great. Green infrastructure is definitely, still very useful, and elimination of illicit discharges. So, if you have a lake with a industrial plant nearby, hopefully that plant is already under an NPDES permit, but if they're not, they should be, and kind of determining who's putting what into your water body. And sometimes it can be far upstream from the water body too. So I know, in a few lakes they've found one lake in California that I was working on, they found like a nursery and then upstream of the water body, and the nursery was using fertilizer to fertilize the plants that they had in the nursery, and they were kind of just, all their runoff was just going into the stormwater system. And at that water body, they were able to trace that back to the nursery, and then, speak with the folks at the nursery and basically tell them like, hey, you are, dumping all your fertilizer into this downstream lake, and it's really causing issues for us. And so then they worked with the nursery to implement some of those BMPs and just implement some behavioral changes and operational changes so that wasn't happening anymore. So, non-structural BMPs are also helpful. Like I mentioned, behavioral changes. So that's just, you know, again, mostly that's directed at like commercial or private landowners. If they're using fertilizer, maybe consider using something else, and then just managing the landscape in a different way. So having more um, uh, impervious or having more pervious surfaces rather than like a lot of pavement, and that kind of stuff. But for more diffuse or complex stormwater sources, so we've got a lot of stormwater sources that are coming into our lakes from locations that really can't be traced back to one singular entity. That is a little bit more complex to control, and you kind of have to take a different approach if you want to actually see some improvement in the quality of that runoff that's coming into your lake. Um, so if you're having trouble kind of figuring out exactly where all of these stormwater inputs are coming from, and you have some point discharge locations into your lake, there are some watershed management tools for direct removal of nutrients at the point of discharge. So there's nutrient binders that you can place at some of these discharge locations. So biochar is a really popular one. And then these proprietary media socks, and they basically, as you can see in the photo here, you just place them near the discharge point, and they sort of they bind the nutrients as the water flows through them, and then you kind of have to change them out every so often, but they do help control the amount of nutrients that are coming into the lake without actually like reducing the water input into the lake. And then tributary dosing stations. I'll get into this a little later, but you can use these dosing stations to basically dose your inputs, or even just the lake in general with nutrient binding. I'll call them chemicals, although that's kind of a scary word, but they are chemicals. Um, you dose the inputs or the lake sediments with these nutrient binding chemicals, and they bind with the nutrients and keep them from mobilizing into the water column where they can be used by cyanobacteria to grow and bloom. Groundwater sources, these really aren't a huge input typically, but if you are having an issue related to groundwater, it's usually a wastewater issue. So septic systems are the big problem with these. So, in rural areas, there's definitely a lot of attention given to private septic systems. So folks who are on a septic system at their private property, those obviously can break or leak and get into the groundwater, and that deposits nutrients via groundwater infiltration into a lake. I think, depending on where you are, some of the local ordinances and bylaws for wastewater management are pretty stringent, but if you're in a more rural area, they might not be. So just improving those, working with local communities to improve some of that management on a agency level can help curb some of the wastewater inputs into groundwater or other receiving waters that might end up in a reservoir. Sanitary sewers that discharge into reservoirs or lakes, or rivers that end up in reservoirs or lakes. I know even here in San Francisco, we have like a combined stormwater sanitary sewer system. So when it rains a lot, our sanitary sewer just overflows into our stormwater and it goes into the bay. And I am not really sure what's going on with that. I think there's some work to try to stop that, because the San Francisco Bay is definitely I don't know if it's an impaired water body, but we do experience blooms on it. So it's something that we definitely need to improve, so that we're not, every time it rains, we're not getting this influx of nutrients into the bay from the sanitary sewer system. So like I mentioned, prevention is always best, but that's tough. There's a lot of inputs into the lake, and it's hard to trace them all back, and feasibly, there's not really enough money to just do all of that investigation to find every single diffuse point that might be coming into your lake. So and then, if there's new development or, redevelopment or something like that, and somebody changes something about how they're discharging their wastewater, staying on top of that, especially if you're in an urban area, that's virtually impossible, given the amount of, development and redevelopment that happens on a pretty daily basis in urban or suburban environments. So I think minimization is a realistic goal, but elimination is really not. So the ultimate point here is that you're always going to have some amount of nutrients coming into your lake, either from urban sources, agricultural sources, or industrial sources. And you can kind of chase your tail trying to control those, but it's kind of where we're at in terms of like the development that's happened in our country and across the world. And I've got these photos here. Green infrastructure is great, but just it will never be the same as the undeveloped land that was previously there. So we're always going to have to find some other way to control the nutrients, whether it's right at the source of the lake or in the lake. The other thing I just wanted to touch on is nutrients can be internally loaded back into the lake. So over time, as these nutrients come into the lake, or they may already be naturally present in the lake, they settle into the bottom sediments, and they kind of live there in the sediments. And during thermal stratification, when the warm water sits over top of the cooler, denser water, they stay there, and the bottom waters tend to become hypoxic, so there's less dissolved oxygen, which allows the nutrients to stay bound to the sediments. But then in the winter, lakes tend to mix. So the hot water on top becomes cooler, and it mixes with the bottom water, and that replenishes the dissolved oxygen in the bottom waters and releases nutrients from the sediments. And they mix up into the water column and become available for algae to use. And that's kind of a lake manager's nightmare, because those folks who have been managing lakes with internal nutrient loading know that when you get these mixing events, they often can cause a lot of nutrient influx into the water column, and they happen right at the end of spring, and then summer comes around and you find yourself with a harmful algal bloom. So in-lake intervention, like I mentioned, it's sort of becoming inevitable at this point. And these strategies are initiated within the water body or immediate shoreline area. They can be chemical, mechanical, or biological alterations, and they're kind of considered direct intervention. So it's not necessarily preventing nutrients from coming into the lake or pollution from coming into the lake. It's just kind of resigning to the fact that we know this is going to be happening, and we've got to do something in the lake to control or manipulate the conditions to have you know, harmful algal blooms be, not make conditions so they're not favored for growth. So this is where that water body, water quality monitoring is really important, because the physical and biological characteristics of your lake are really important to what in-lake intervention strategy you can choose to use and which ones are going to be effective. Um, Also, the nature of the bloom, whether you've got a recurring algal bloom, it's happening every year, or if it's just kind of a one-off one, where it is in the water body. Planktonic blooms are sort of throughout the water column, and then benthic blooms usually live right on the bottom. And then, of course, you have to work with officials and stakeholders. There's infrastructure requirements, costs, just what's available to you. So I've got this list of some of the most popular treatment strategies, and I don't want to go into all of them too much because I want to, kind of speed through to the nutrient inactivation. But these are the most popular, throughout the country. Um, some of them are mechanical, where you're kind of doing artificial in-lake hydraulics. So oxygenation and aeration, that's a really, really popular one, especially here in California. But again, it doesn't always work. There have been lakes where people put oxygenation systems in and they're kind of like thinking it's going to work and it should fix all their problems, and it really doesn't. So that just speaks to the importance of understanding your water body and what is going to be effective and what's not. Chemical applications. So this includes the nutrient inactivation compounds, so the phosphorus binding compounds, and then a variety of other chemical applications. Peroxide is a popular one. Algicides, those ones are pretty popular for like, I would say if you have like a one-off bloom. If you've got a recurring bloom, then you probably don't want to be applying peroxides and algicides to your lake every year. But if you've got like a one-off bloom, these are pretty effective in getting rid of that. And then biological, these are a little bit like, I would say maybe less popular. Barley and rice straw is like not very effective for a large system. Food web manipulation has been effective, but it's kind of controversial. And then monitored natural attenuation, which is just the do nothing strategy. And it can be effective for certain lakes, but I think most folks want something that is a little bit more of a direct intervention. And then there's some emerging technologies. Again, I'm not going to go into these too much. They're pretty new, and some have shown to be effective and some have not. I did talk with a guy who was using ultrasound on his lake and said that it was working. So that was pretty cool. I asked him to send me the data, but I'll have to follow up with him. So these are some of the more like niche and emerging options available, but some of them haven't been tested in the field widely. So it's the jury's still out on whether they're super effective. And then permits. Nearly all in-lake intervention strategies will require some sort of permitting or approval. So planning is really critical. And if you're going to deploy a structure in your water body, the Army Corps might need to be involved, additional approval if you have endangered or threatened or special status species. All algicides require an NPDES permit. And some copper-based treatments in some states have restrictions, and obviously always involve your state water quality regulatory office. They will be able to direct you on what is and isn't appropriate. So I've left myself about 2 minutes to go over this case study, but I'll just zoom through it. But we did implement a nutrient activation treatment on a reservoir is this in Rhode Island, I think? So it's called Misquanticket Reservoir. It's not a drinking water reservoir, but it feeds into a drinking water reservoir, and it was experiencing recurring algal blooms. So we did a nutrient budget on the lake and found that a majority of the nutrients were coming from internal loading in the sediments. So that led us to believe that a sediment targeted nutrient inactivation strategy would probably be the most effective strategy for this lake. For a number of reasons listed here, but definitely because of the nutrient budget, showing that um, the internal loading was the main source, one of the main sources of the nutrients to the water body. So in terms of the nutrient inactivation compounds you can use, I've listed them all here, but the most frequently used one is aluminum sulfate, which is just called alum. It's kind of typically considered the cheapest, most widely available. It's sort of the common brand one, whereas these other ones are a little bit more like commercial brand. And the goal of all of these compounds is to stabilize the phosphorus and keep it out of the water column where it can be used by algae to grow. So again, it's most effective for lakes where excessive phosphorus is driving the HABs. And there's some different application strategies, dosing stations I did mention. But earlier, and I believe there was some dosing stations installed on this lake as well to intercept phosphorus from the external sources coming into the lake. But we also applied sediment dosing in this lake as well. And you can see in this picture the flock from when we applied the alum to the lake. It basically just strips the water column and then settles in the sediments and keeps the phosphorus bound there. You can buy it at the supermarket, I found, but don't use this version for lake management. And so we implemented this strategy in April 2018. And you can see we monitored pH and turbidity. Alum does have an impact on the lake's pH, so you will have to monitor it and make sure that pH doesn't get too low, because then you can that poses a risk to some of the other biological critters that are living in and around the lake. And so that's where the sulfate kind of comes in, as it helps stabilize that pH so that you don't get too acidic water in the reservoir. And overall, the management strategy was a success. Pre-intervention, the lake clarity was pretty low, especially during harmful algal blooms. But then post-intervention, we were seeing an improving lake transparency, turbidity likewise improved. The chlorophyll A also decreased, which is kind of an indicator of harmful algal bloom presence. And then the total available phosphorus also increased or decreased post-intervention. Oh, there is a little video here, but I'll play it, and then we can, I know I'm like, a little over time, so I'll just take questions. There's no sound in this video, but it just sort of shows some images and videos from the alum treatment, and just kind of gives a nice overview of it. So yeah, I think I'll just end it there. And as we watch this lovely video, we can take any questions. And I know I'm over time, so if people have to leave, that's also totally fine.
Yeah, thanks so much for the talk, Amelia. We do have, we are over time, and if people have to leave, that's fine, of course. We do have some questions in the chat as we're watching your video here. Um, Matt asks, how much water can be effectively be treated using biochar or these proprietary socks at the end of a stormwater pipe? Any idea on what that limitation is or capacity?
Oh yeah, like before they have to be changed out. That's a good question. I don't really have an exact number. I think, it will also depend on, exactly which type of sock you use. I think, you know, like all of these products, you purchase these from a vendor, and, they'll give you kind of the stats on those types of questions. So I can't say for sure because, again, it will depend on exactly what the vendor provides you. Um, but um, yeah, I don't that not a very good answer to your question, but I would say depending, yeah, just ask the vendor. They can provide you with that information. But I think, typically they're designed to withstand like at least a year, I would think. But it also, depends how much rain and runoff you get in that year.
Emma asked a question. I'm not sure you can address it or not. She writes in the chat, I've learned that some farmers apply water treatment residuals to land for crop production. Do you know if there are cases where the residuals contain microcystin HAB toxins when applying to the land? And if so, are there risks to the watershed?
Oh yeah, so using, like using almost like human waste, I guess, as like a fertilizer. Yeah, that's definitely an issue. And I don't think it is, I think in some ways people thought that was a solution to using traditional fertilizer, but it certainly is not because human waste also contains phosphorus. So I don't have any, distinct metrics or examples, but the same way that agricultural runoff and waste from, livestock waste will contain high levels of nutrient. Um, you know, Human waste will also contain high levels of nutrients. So it's really not a very good substitute in terms of using it as a fertilizer or, um, I know in the main lake that I mentioned earlier, they had issues with a farmer using like chicken waste. They tried to switch to chicken waste as the fertilizer, and that just actually made things worse. So I really think any kind of biological waste that's applied as a fertilizer is still going to contribute high levels of nutrients to the runoff that comes off of that land.
Yeah, I think one of the things that Emma was interested in, if I can read into it,
Mm-hmm.
is wondering if those residuals actually contain microcystins and
Oh,
toxins, or I mean, I think that was the nature of her question. I don't even
okay.
know if that's knowable, but
Um,
any musing on that?
yeah, they could. Certain drinking water plants are not equipped to treat microcystins. It sort of depends on the water treatment facility. Some water treatment facilities have implemented treatment strategies to directly address microcystins in water because it has been an issue for the water, whatever water source they're using to, or whatever water source they're treating. But I think, yeah, that will be a facility by facility um, issue, and some facilities will be able to remove it and some facilities won't. But I think for a wastewater facility, they probably are not as equipped to remove that as say, a drinking water facility. So
Sarah asks the natural follow-up question here. Are there any known risks to fish species from any of the treatment applications that you discussed?
yes, yeah, there definitely are. Like I mentioned with the alum, when you are applying that treatment, the pH levels can drop. So you have to be super careful and make sure you're adding a buffer in addition to the alum to keep that pH from going too low, because that can affect fish. Certain the copper compounds that I mentioned, the reason that those are pretty, some states have actually just banned them outright. So those have been shown to affect the fish populations and be toxic to fish. So that can be an issue. And certain algicides will also impact fish populations as well. So again, that just kind of points to knowing your reservoir and knowing your water body. If you have sensitive fish species, or just any kind of sensitive ecological consideration, a chemical application might not be an appropriate strategy.
And maybe we have time for just one more question. Kristen asked earlier in the chat, we work at the state level. And of course, Minnesota has a lot of lakes. We leave regular lake monitoring up to 2 to 10 year visits, up to local government units, as well as beach closures. What should we at the state level be doing related to these HABs to support our local government units? Any thoughts on that from your experience?
Yeah, well, one of the big things I think that was heavily emphasized at this latest conference was citizen science initiatives. So, and it kind of sounds like, just get the community involved. But it is really effective to get the community involved, because there's only so much we can do as lake managers. We can't, we're not necessarily out on the lake every single day. So to the extent that you can involve the community who is using that lake and recreating on the lake, so that they can identify, oh, that looks like a harmful algal bloom, or oh, that like doesn't look so good. I noticed some dead fish on the shoreline, that kind of stuff. That really helps state agencies determine where the problem areas are, so that they can react quickly. And then also, following up with them as well, and encouraging the community to follow up with them, because I know, at least in California, when a harmful algal bloom is reported, there's a lot of follow-up investigation and stuff that they do. And when the person who reports the HAB, or a HAB-related illness, sort of like disappears after that report, they can't really complete their investigation to the extent that it should be completed. So I do think in this respect, engaging the communities who recreate on those lakes is really important. And another thing that was really heavily emphasized is engaging the indigenous tribes in the area. A lot of these lakes have been previously, they are on land that was previously indigenous land, and the lakes are still really important to the indigenous communities. And a lot of times they feel really left out, that they can't do anything to protect this water body that is very important to them and their culture. And I think a lot of lake managers and folks in general have found a great ally in these indigenous tribes. They really are motivated to protect these lakes, and they really are the original stewards of the land. So there's a lot we can learn from them. So.
Great. Hey, Amelia, thanks so much for joining us early out your way, and glad you could make it in and give us this talk. It was great.
Yeah,
Thanks
thank you.
again. Thanks again for giving it.
Thanks for staying a little late. And yeah, feel free to reach out to me. I also put my coworker, Matt Ladowig's name on here, because some of these were his slides that I just stole. So.
All right. Thanks, Amelia.
Okay, thanks
Yeah.
everyone.
Yep.